Welcome back to the Val Studio. I got up this morning, I went right back out in the shop, and I'm going to cut me some more of those test plates. Every plate I cut ended up getting worse, and I crashed the machine a couple times, and then I eventually burned that bit out. So I started off my Monday on a really bad note, and the rest of the day was horrible. But I ended up getting out there and making one right at the end after I had some research and a little discussion with my friend Rob. I'm going to go ahead and show you what ended up happening. In yesterday's video, I was cutting it. The 200% override was about 1,000 millimeters per minute. And somebody said I needed to go faster than that, so I turned it up. And every piece that I made had excessive tear out, and I ended up burning a bunch of the pieces. They got progressively worse. And you can kind of see that little notch I cut over there by hand. It's completely dark. And this was one that I actually crashed the machine on. And for some reason, the Z height on my G-code was bad. And then eventually this was the real disaster. I was doing yet another one, and you can see the excessive tear out. And it was really going slow, and the machine was really having a lot of problems. And I cooked that bit so hot that it kind of got loose in the collet, and the bit actually got pulled out of the collet and went right into the spoiler board. So in that top hole at the end of that stretch is probably about a half-inch deep hole, and then the machine just stopped right there. So if you look at the bit right here, you can definitely see that it's got torched. And we'll go ahead and show you how that started here in just a minute. But I'm going to zoom in on that, and you can kind of see this bit's destroyed. There's no edge on it anymore, and it actually has a couple of really bad dings in it. And I don't know how that actually happened. I didn't hit any screws or anything. My spoiler board's MDF, and somehow I got a notch in there as well. So I need to learn about feeds and speed, so I started out by watching Winston Moy's feed and speed video, and this is actually really good. And he talks about the countless hours that you could spend watching them. He just kind of advocates going over to the custompart.net milling feed and speed calculator. So if you put in everything in here for what I'm doing, my speed came out to be really fast. Incredibly fast. So I didn't really know what to do about that. There was two other links that he had in the bottom of his video. The next one he said was go over and watch this one from NYC CNC. John here talks about this is a whole series on carbide tooling. And he spends a lot of time talking about feeds and speeds of carbide tooling, but my bit was a high-speed steel. And, he's a, professional machinist, so he's doing aluminum and steel and that kind of thing, not wood. And then the last one I went over and I watched the ones from Applied Science, and he talks a little bit more about feeds and speeds. And he's getting more and more complicated as you go along. But they all kind of, bring up the data sheets for the bits, and they go from the manufacturer's recommendation and your chip load and how big the chips are and the sound and everything. And so I didn't know what to do at the end of the day here. I went over and talked to my friend Rob here in town. He's been a machinist for about 20 years, and I kind of showed him my bit, and he just started laughing, and which is fair, and I showed him some of these pieces and told him what had expired over the day. And he said, well, let's open up the feeds and speed calculator from SolidWorks. And so he did that, and we found that Luon has a specific hardness, and what we were trying to do with a 2-flute end mill. And his calculator came up with this outrageously fast feed rate, and he talked a little bit about surface feed per minute and how you really need to take it fast. But I can't get it that fast. He said, that's unrealistic. I said, okay, well then now what? And he said, well, what's your minimum speed on your router? And I said, it's 10,000 RPM. And he said, well, you're not going to be able to go the speed you should be going with that and get the chip load you're actually looking for. And I said, okay. I mean, people use these routers all the time for woodworking. And he said, well, you go ahead and run the router really slow, the RPM, really make it as slow as you can get it. And then start out really slow with your feed rates. And you should get a feel for what it sounds like, and try to stay away from these theoretical calculations for that, because my spindle is actually way too fast for what I want to try to do. But people are using Shapeokos for years now doing woodworking. So I came back over this evening and I measured the RPM. Let me go ahead and show you that. Here's my tachometer reading with the Makita on value number 1 on the speed control. That's about 10,000. 2 is 12.5. 3 is 16,500. 4 is 22.4. Here's 5. 5 is about 27. And 6 ends up being 29,700. So it's about 30,000. So yesterday's success was almost a pure accident because I was going slow at 30,000 RPM. I'm actually making chips only because it was sharp. And when Rob and I went back and looked at the video from yesterday, we ended up seeing that the bit was actually started to burn a little bit after my first couple passes, and then it just got excessively worse. And so what I was doing was running so fast that, and then I was just kind of burnishing the wood and burning it, and that's what ended up happening. So I went back out, like I said, and I got a different router bit. The one I'm using for this cut was a 1/4-inch down spiral bit. I set the router speed to the lowest setting, which was 10,000 RPM, and then I reran the job at about 400 millimeters per minute, which is quite slow, but the results on this one are really superb. Because it's a spiral, I don't have any tear out on these. The bit came down from this side. I don't have any tear out. I got my heights correct so that the bit barely goes through this and barely comes in contact with the spoiler board. And so when I measure these, this distance here is 100, which is what I expect it to be. Same with this one. This is 50. This is, that's 50. And these are meant to be 15, but they're not. They ended up coming out to be about 14.75. And when I talked to Rob about this earlier, he said that I have to do this as a separate, I have to really slow down for this because of the tight radius. The bit's actually moving really quickly. And so my surface per minute goes up because I'm cutting such small circles. So he advocated that for every reduction in radius by 50%, I should go down on the feed rate also by 50% on these ones. But I'm really happy with this one here. And there's no burning, there's no discoloration of the bit, there's nothing. I guess that what I'll do is keep going with this Makita. Run everything for my wood projects at slow RPM. You can't really slow it down, the motor down, any more than that if you were to use like SCR controlled motor controller, because you'll probably end up losing the torque that you need for the cutting operation. Might end up looking at getting a 3-phase real spindle for my open beam for my Hyatt machine, but we're going to go with what I got. At the end of the day, I burn up a $14 high-speed steel bit. on some scrap Luan, and from a learning experience, I learned that I really need to take feeds and speed seriously. And it turns out that my problem is not really that calculable, or it is, except I can't run my machine that fast based on the theory. So we just have to take it slow, and I have to use my ears to see if the machine's struggling or not when I'm cutting. All right, well, thanks for watching. This is the Valve Studio.